Hello, this is Mr. Buss, and we'll go through how to work on these problems. Plasmid restriction mapping. Okay, so remember, a plasmid is a circular DNA structure that occurs in bacteria. And okay, recall that restriction enzymes, and in this example we're using EcoR1 and BAMH1, and depending on the sample, it was either cut just by EcoR1 or just with BAMH1 or with both of them together, okay? And so this plasmid is 20 kilobases, 20 kb, so the whole thing all the way around is 20 kb. And if we cut this thing with EcoR1, okay, right there, notice that it would just make one cut. And so we would end up with one fragment that is the size of the entire plasmid. So EcoR1, size of the fragment would be 20 kb. Okay, and if we cut this thing with BAMH1, notice that it'll make 3 cuts, one there, one there, and one there. So we'd end up with fragments that are 2 kilobytes, or not kilobytes, 2 kilobases, 6 kilobases, or 8 plus 4 is 12, 12 kb. So 2, 6, and 8. Or I'm 2, 6, and 12. Okay, and then of course, if we use both of them, right, then we make all those cuts, and then we're going to end up with a 2, a 6, an 8, and a 4. Okay, so that's how that works. Those, so let's go ahead and look at number 2. We're going to do this in reverse. So number 2 gives us the opposite information, and we have to, excuse me, we have to form the plasmid and show where the cuts are going to be. Okay, so this is kind of similar in looking at it. The first restriction enzyme that's used is HPA1, and it just has one 26 kilobase fragment. So there must just be, I'll use blue for this one. Actually, I'll use blue for this one. So let's just put, you can put this cut anywhere, honestly. Let's put it right here. All right, and just copy that. There. Okay, so there it is. The whole plasmid itself is 26 kb. Just get one fragment, 26. If we use the HIND3, it's going to make 4 cuts, and one of them, this one, must be in the middle of the HPA1 cut, because notice that I have, these are the same, these are the same, and these are the same, right? So this HIN3 cut must get cut by the HPA1. So I'm going to put on either side of the HPA1, I'll use a red for the HIN3. I'll put a 7 and a 6, and that's going to equal 13, which would be like half of this thing. So I'm going to go like, maybe here's the 7, and maybe here's the 6 kilobyte section, so that the whole thing here, from there to there, would be 13, right? Okay. And then the other cuts are a 6, a 4, and a 3. 6, a 4, and a 3. So honestly, you could put those kind of anywhere down here, and it doesn't really matter. It's going to be impossible to tell exactly where they are. So here's a 6, here's a 4, and a 3. So then let me label those. Okay, so this would work if I look at these cuts here. This would form all those fragments. If I use both of them together, I'll end up with 7, 6, 6, 4, and a 3. Yep, 7, 6, 6, 4, and a 3, and so on. If I just use the hint 3, I'll end up with a 13, a 6, and a 4. Yep, a 13, a 6, and a 4, and a 3, and a 3, and so on. So that's going to work. Okay. This next problem, we're going to cut a plasmid with a combination of restriction enzymes, BAMH1, EcoR1, and PST1. Okay. And then those fragments are going to be run on a gel, and the question is asking you to predict where the bands would be. Okay, so we already know the size of the fragments, so we're not having to figure that out. We're given the size of the fragments as, like, here's a 0.2, here's a 0.46, here's a 1.94, and so on. And we might have to add some of these numbers up depending on where the cuts are made. Okay, so for the first one, let's take a look at EcoR1 and PST1. If we add those two, what would be the size of the fragments? So if we cut with EcoR1 and PST1, we would end up with a 0.46. And then we would end up with a fragment that would be here, because BAMH1 isn't going to be used in this first one. So it would be 1.94 plus 0.2, which would be 2.14. So we'd end up with a 2.14 section, and let me write that. That would be a 2.14, right? And then a 0.46 section. So let's go ahead and look at our gel. There is the left column, which is with some size standards. So we're going to have to estimate where the lines would be. I'll do the 2.14 one first. So 2.14 would be somewhere between these two, right? And it would be closer to the 2.2, so 2.14 would be maybe like that. Okay. And then the 0.46 would be slightly less than that. So 0.46 would be maybe right there. All right, now let's do the next one. What if we, I'll use a different color here. What if we use EcoR1 and BAMH1? Okay, so there'd be a 0.2 kilobyte section and a 1.94 plus 0.46. Let's do that. 1.94 plus 0.46 is a 2.4. So we'd have a 2.4 section and a 0.2. Okay, 2.4 would be maybe here. And a 0.2 would go pretty far in here. Right about there. Okay. Next would be, what if we use all three of them? Okay, if we used all three of them, then we would have a 0.2, a 0.46, and a 1.94. So a 0.2, 0.46, and a 1.94. Okay. So that is how to predict where the fragments from a gel cut would be, a restriction enzyme cut, and how those fragments would look on a gel. Okay, and then number 4, we're going to go in reverse. So here we have the gel, which this is actually be more realistic. You'd run the gel and then try to deduce where the cuts were on the plasmid. So let's go ahead and try that. So the first thing I noticed is that EcoR1 only made one fragment. So that must mean that there's only one restriction site there. So I'll just put it right here. And let's do this. Okay, so there's an EcoR1 cut site. Okay. And then that would be a 20 kilobase. So the whole thing is 20 kilobases all the way around. All right. Okay, now that 20 kilobases, what if we look at this here and say, okay, looks like these two are the same here. And we've got two of the same here. But then it looks like we've got an 11 that gets cut into an 8 and a 3. So this 11 that gets cut into an 8 and a 3, that must surround the EcoR1 somewhere, okay? Because the EcoR1's cutting that into an 8 and a 3. So I'll put the 3, I'll use a different color here. I'll put the 3 on this side, and I'll put the 8 on this side. All right, so that fragment that the BAM-H1 would leave an 11, and 11 is a little more than half of this, so I'll kind of make it look like a little more than half. Okay, so there's two of the BAM-H1 sites that would leave an 11. And then I have to put a 6 and a 3 on there in the remaining places, which would be 9. And I don't know, they're gonna go somewhere here. I don't know exactly, and actually I would never, with this information, I'll never know where the 6 and the 3 would go. It could either be the 6 like that and the 3, or it could be like that. Okay, so there's a 6 and a 3. And then again, those are the BAM-H1 cuts. Okay, so that's one way that we would be able to map that one. Oh, given a gel. All right, number 5 is a little bit more intense here. So I'm going to stop the video, and then I'll make a separate video in case you want me to solve 5 and 6. All right.